Alright, Logic fans, welcome back to our third video on section 3.3. This is video 3.3c, and we're continuing our discussion of the important rule DeMorgan's. We left off, I've switched things up a little bit here, but we left off talking about this particular case here, and I wanted to make the point that this is forbidden. This is not a correct application of DeMorgan's. So you distribute it in, oh wait. Nope, I take it back. Sorry, this is correct here. What happened? Right, so this one was correct. You distribute it in, and you're left with the two here. Do not remove these. Okay, if you want to remove them, you have to use double negation in a separate step. That was the point I wanted to make there. Okay, so the strict application of DeMorgan's is to this, which is correct. Now, if you have the same given, and you try to go to this, that's incorrect. Right? Because you're distributing it in. Where did this extra thing come from? Right? You're not allowed to make any other changes. Alright, so this one is forbidden. This one is permissible. A-OK. Go ahead and do it. Now, go ahead and try these last two on your own for a second and see how you do with it. This one and this one, are these legitimate applications of DeMorgan's? Pause now. Okay, let's go ahead and go through these. So as you've seen, all right, and my point here is to give you the same given, and then the person's trying to do different things and what's permissible and what's not. So this one was permissible. This one was forbidden. This is also forbidden. You cannot just disappear these two. If you want to get rid of the two, you have to apply double negation in a separate step. One rule of inference per line of your syntactic deduction. That is a hard rule. All right, do not violate it, okay? And there's excellent reason for it. The whole point of logic is to make explicit, right, that one thing does follow from another, and so we want the steps to be as perspicuous as possible. All right, so this one, when it was to this, is impermissible. What about this case here? Is that permissible or impermissible? Well, this is permissible. This is okay. You can go ahead and do this. And my point here was to just show you that, you know, even though this whole thing here is a conditional, okay, the fact of the matter is that DeMorgan's is a rule of replacement. So we're going to go inside of this conditional. In particular, we're going to go inside of its consequent, and we're going to use DeMorgan's to rearrange some things. And that's perfectly allowed because DeMorgan's is a rule of replacement. Okay, let's look at a fun construction I want to show you that often comes up in the problems for you to solve that involves DeMorgan's. Neat little trick of the trade here. Okay, so I've got a little bit of a deduction set up here for you, and this is a really interesting thing because all you're given is this meager resource, not B. And from that, you're supposed to be able to build this big, long, entire string. Pardon me, it should be... One second, something's wrong. It should be just like this, okay? So you've only got not B, and from that, you're supposed to be able to conclude it's not the case that both B and C. And this is a really nice build to be able to keep in your back pocket as a problem-solving technique, okay? So I'm going to show it to you here, but first let me give you a chance to do it. So there's one line that has to get filled in here, and then you have to put the justifications, the rationales for both of these. So pause now and give this a try. All right, hopefully you got it, but in order to set this up, right, you want to set up a DeMorgan's. So you can do not B or not C, and that's by add on one. And by adding, we didn't just add C. Notice we added not C, which sets up DeMorgan's perfectly, right? And so that allows for this. So this is a really, really nice trick for you to remember, okay? And you may find that useful on a homework or an exam problem. And in the exercises in my book, I do walk you through this kind of construction. So be on the lookout for those kinds of things. I mean, it is amazing. You can get from this little thing to this big thing in 2 steps. Pretty cool. All right. Okay, we are now approaching our final rule of the day, okay, and this is our final rule of the day, distribution, abbreviated Distr, okay, whoops. And like DeMorgan's and association, Distr has 4 possible applications, but once you see the pattern, it's pretty easy to remember how they all go, so it looks a little bit more intimidating and worse than it is. But let's just start with this one, okay, so let's start with this first one here. What you're allowed to do, okay, distribution essentially involves an and also an or. And what it'll allow you to do is it'll take an expression like this and you can expand it, okay? So you can expand it to P or Q and P or R. So think about this just semantically for a second. If P is true and either Q or R is true, then it's going to be the case that, pardon me, I got this wrong. I apologize, I got that wrong. I've straightened it out now, so this is right. So we're looking at this one, P and Q or R. So either P is true and either Q or R is true. So basically what you can do is you can take this and you can expand it to, so either both P and Q are true or both P and R are true, possibly both. Alright, so we've sort of expanded it, and notice what you do is you switch the main connective from the and to the or, and the one that's in between switches as well. So that's an easy way to remember how to do it, okay? Similarly, you can go the opposite direction, so you can go from this guy to this guy, and that's all that I'm saying here, okay? So if you've got the P here, right, and the P here, and you've got the or, the ands, okay, then you can switch the main connective, isolate the P by itself, so instead of expanding from this to this, you can contract from this big guy to this smaller guy if you want, okay? And then basically all I'm saying over here is that, yeah, if you reverse this to an or and this to an R, the same thing. And you can do it both directions. So P or Q and R can expand to P or Q and P or R. Similarly, if you have this thing, you can contract it down to this thing, isolating the P there, okay? So sometimes, in order to apply distribution, you have to set things up, right? So you might have a situation where the R is here, for example, and the P is here, and you might want to use Comm right there to get the P over there and the R over there, just to set it up the right way so that the P is on the left side in both situations, all right, and those kinds of things. So let's go ahead and look at an example. Okay, so I ran out of a little bit of space here, but the idea is that you know, you've got these two, and then you've got this one, and remember that for this one you can go from this to this. You can contract as well as expand. Okay, so go ahead and give this problem a try. I'll give you a hint for it in a second, but from this string, syntactically deduce this string. Pause now. Okay, so I'm going to give you a hint. I've done it in 4 lines. If you do it in more lines, that's absolutely fine. That doesn't mean that you're wrong. The efficiency question, what's the fewest amount of lines as possible in a given system to do it? That's a sort of computer science question. I'm not too concerned with that here. I just want you to get it. It doesn't, if you do it in 100 steps, fine, as long as each step is correct and you end with what you're supposed to get, which in this case is this construction here. So let me ward you off of a certain path. So you might have been tempted to try something like this. Let's do it this way. It would be something like this, and this, of course, would be DeMorgan's. Okay, so this would be DeMorgan's on 1. Now, this is a perfectly legitimate application of DeMorgan's on 1. So that's not an issue. The issue is that now you can't use the rule of distribution, okay, because of this pesky negation here. If you had something like this, right, and you wanted to use distribution, first of all, you've got the 2 ors, so you need an and, but you would have to distribute it through to get this, all right, distribute it through, meaning apply DeMorgan's on this to get this, and now you're ready for a distribution setup, okay? So with that hint and warning about you know, not to do that in this particular case, go ahead and see if you can complete the syntactic deduction. Pause now. Okay, so I'm going to walk you through this, and I want to show you how I remember distribution and how it works. Okay, so in this particular case, I'm going to be expanding it as opposed to contracting it. So I've got my OR, and not A is P, right? Not B is Q, not C is R. The whole thing is R. So what I'm going to do here is I know that my main connective is going to be AND, so I'm going to switch my main connective. And I'm going to have something on this side, and I'm going to have something on this side. So I've got a construction that looks something like that, where the main connective is now AND. And in here, the main connective inside of these parentheses is going to be OR. Right? So I'm going to have something that looks roughly like that. Okay? And the question is what goes in each of these slots? Okay? And, well, I know that my P is going to go on the left side of both of these. My P in this case is not A. So I'm going to slip in not A here. And then I'm going to have my Q and my R. So my Q is going to go here, and my R is going to go here. In this case, my Q is not B. So it's going to look like this. And this is going to be not C, which is my R. And I'm going to write distribution on 1. Okay? And that's exactly how I sort of fill things in. First, I sort of fill in what's my main connective going to be and what's going to go inside the parentheses, okay? So I hope that you find that technique a little helpful for remembering it and accuracy purposes. All right, and then, of course, what I'm going to do is I'm going to simp out this, all right? So that's going to be simp on 2. And now that I've got that, I can, of course, what goes here, right? DeMorgan's on 3. Perfect, and that is the deduction, okay? Now, as your sentences get bigger and longer and more complex, oftentimes spotting a distribution application can be hard. And even once you've spotted a possible distribution application, understanding exactly how it works can be hard. So let me give you an example like that so that you have something to model it on. So go ahead and try this one, right? It just looks like this horrible, nasty thing, but if you start thinking about it in terms of P's and Q's and distribution, P, Q's, and R's, it might make it a little bit easier to figure out how to get from 1 here to this big, horrible, nasty thing. Pause now. Okay, so this is a one-step case, but I'm going to show you how to think about it in a way that hopefully makes it more intuitively clear to you. So in some scratch work down here, away from our formal deduction, okay, we're going to have and the key thing is to sort of think about the premise in such a way as, can I see a possible distribution application? Well, there's lots of different things to look for, but in this particular case, notice you've got the C here, and you've got the C here, okay? And distribution is a rule of replacement. Therefore, it has the ability to go inside of this whole sentence and just sort of work right in here if it wants to. So you've got the C here and you've got the C here. The rest of the hint falls in pretty quickly when you see that because you've got, oh, I've got an and I've got these 2 ors. So this is the expanded form, and I should be able to shrink it down. So what I want you to do then is just, again, on this scratch paper, okay, I'm just thinking about this part, right? And that's going to be, you know, pretty straightforwardly something like this, right? Where you've got P or Q and P or R, right? Where P is C, notice it appears twice, and Q is D, and R is F, right? And we know that from our rule, and actually, unfortunately, we are running a little low on time, and I don't want to rush this discussion, so I am going to spill this onto another very short video to round out this discussion. All right, see you on the next one, which is going to be the very short 3.3D.